Perfect. So this is the expression that if V volume H2O2 is there, its molarity is V upon 11.2, normality is V upon 5.6. Percentage strength, if you want to calculate, then it is basically molarity multiplied by molar mass of H2O2, which is 34, and divided by 10. So what is percentage strength? This I have explained here, that the mass of solute in gram, volume of the solution in ml into 100. So if you derive it, you will get this. So either you use it in this way or whichever way you want to use it, right? So this is it about this problem. Now tell me any other doubt if you have.
Sir, fourth one.
All right. In basic medium, H2O2 acts as an oxidizing agent in reaction with. Okay, it is saying H2O2. All right, in basic as an oxidizing agent with with. So can't you guess directly? You can guess this question also. Even if you don't know, you can get it. Like silver is in already +1 state. Iron here is in +3 state. I hope you know how to calculate it, right? So overall, if you go by the rule of X, then potassium is 1 into 3 plus X of iron into -1. That is equal to 0. From here, you will get X as +3. So X is equal to +3. Here chromium is already in +6. So they are already in their higher state. So only one chromium is there, which is over here, which is in +3 state. So even if you are simply guessing it also, you will get the right answer as A.
Sir, but how to decide whether is it in basic medium or acidic medium?
Basic, see, that was the only option for this. What I am right now telling you is to look at the tactics of solving the problem, right? Or otherwise, in the morning time, I told you, and I have prepared a notes I will share with you. You can go through these reactions, right? So here are the list of the reactions. I have completely described it because of I consumed a lot of time in discussion of the doubt. That's why I couldn't finish this. I couldn't give you the note of it. So as I told you about H2O2, that it can act as oxidizing as well as reducing, acidic nature, disproportionation, all of them, right? So here I have given a note for you. I will share immediately. I will share after this discussion. So look at this. In acidic medium, you look at H2O2 plus H plus ion I have taken, and you can see that I minus converted into I2, sulfide into S0, which is a turbidity. Turbidity means which floats over the surface, right? Then sulfur in +4 is going into +6. -2 PBS is very uniquely going into +6. And this reaction is very special. As I told you in the morning also, that this reaction is used to regenerate the color of old paintings, because with time what happens, lead forms PVS, black precipitate over the paint, which basically uh, basically it darkens the color, right? So if you are using it, it will become white once again, PbSO4, which will regenerate the color. Then again, nitrogen in +3 is going into +5. Arsenic from +3 to going +5. Iron from +2 to +3. Again, iron in K4FeCN6, which is in +2, it is going into +3. So these are all reactions of H2O2 as an oxidizing agent. An oxidizing agent also it can, here are the values I have given. In acidic medium, you look at the E naught value, it is very high. So for now, you understand as E naught more means delta G less. And if delta G is less, this is more favorable. So more E naught means more favorable. You look at this value. So that's why I told you in the morning that H2O2's action as an oxidizing agent is more better in acidic medium. You can look at the value and comprehend it. 1.776 and here it is 0.878. Right? These are the data I just gave you to fetch your need. Now there are certain reaction in basic medium also where it acts as basic medium. Sorry, it acts as oxidizing agent in basic medium. Like I minus can be oxidized in basic medium from -1 to +5. And in acidic medium, if you remember, the same I minus, my dear, in acidic medium is going into I2, whereas in basic medium it is going into IO3 minus. Then many students ask one doubt, sir, don't you think that it is more powerful in basic medium? Guys, am I audible?
Sir.
Then many students ask this doubt, sir, you see, +5 it is going, sir, here in acidic only 0. So my dear, it is not the power of H2O2. It is basically related to iodine. I2 is not stable in basic medium. If you take base now, it is not stable there. So that's the reason I2 is not formed in basic medium. We get IO3 minus, which is KIO3. So that's why straight away from +1 to +5. So this reaction I would like to highlight, because if you look at Ki is going I2 in acidic medium, whereas in basic medium also oxidation is taking place and going here. Like that, you can see that even chromium hydroxide in +3 going into chromate +6, again green to yellow. These reactions you are supposed to learn through these examples. That's how you will know. Otherwise, you apply a common sense and think about it. You will get in that case also. Right? It's not necessary to mug up all the reaction. You can have a common sense. And one thing which you can never guess is this one. This is very rare and very unique reaction where formaldehyde is converted into formate. It is okay, but the H2O2 part, means this one, is actually converting into H2. It is very, very rare. Right, so that's what I have written over here. Oxidizing formaldehyde, which is HCHO, into HCO minus, but H2O2 reduces to H2, which is unlike other reactions. Right, it is not like the other reactions where H2O2 is going into water. So you can write like this, that H2O2 oxidizes formaldehyde into HCO minus, but H2O2 but itself reduces to H2, which is very, very, itself reduces to H2. It is very, very rare. Okay. So these things are not common. So this one you can't guess. For that, you have to refer the notes only, right? And here also to some sort you can't guess, because generally manganese in +2, there are many compounds of manganese. One of them, that is MnO4 -1. So it is in +7 state. So you can think that it is going into +7, but it's not like that, my dear. +7 is not stable in basic medium. So that you will come to know so many times if you'll revise and if you'll read D blocks and all of that, then you will know. So here also you are supposed to learn. These things you can't do. You can't guess basically. So for this you have to simply remember there is no other alternate of this. And that will come by multiple time revision. That's why I am telling you again and again. Inorganic, if you want to be better, you are supposed to read it as many times as possible. So these reactions. Similarly, as reducing agent, H2O2 as reducing agent, both the medium, basic also acidic, but in basic it is better reducing agent. So I have given the reactions. Like in acidic medium, KMnO4 goes into this and H2O2 goes into O2. So one of the key feature of in which reaction this is acting as an reducing agent is whenever it will undergo oxidation, it will always produce O2. So if you are getting O2, be little alert that it could be because of oxidation of H2O2, means it is acting as a reducing agent. Not many reaction in which it acts as reducing agent, very few of them are there, which I have reported. 1, 2, 3, you can simply number them like as 1, 2, 3, 4. It will be easier for you to memorize it. Now, the second question comes there, sir, how do we know that where it will go? See, there are limited number of oxidation state of a particular thing which are stable. Like if you'll ask me, Mn, so I can tell you, dear, one is +7, which is stable, one is +4, which is stable, other is +2. +4 is not stable in acidic medium, right? So the only option left is +7 and +2. It is already +7, so it is going into +2. Similarly, you see +4 is there, so it is quickly going into +2 in the presence of H2O2, right? And chlorine, my dear, where can it go? It can go into Cl minus straight away. This is the most stable state of this. Like that PbO2 +4 to it can go into +2. So like that you have to see that, right? Iron, where can it go? Right? This is the reaction in basic medium. H2O2 as a reducing agent. Wherever it is acting as a reducing agent, you will get oxygen. I'm highlighting every time, so that you should not get any kind of problem with it. Everywhere you will get oxygen. This is the identification that H2O2 is undergoing oxidation, right? Okay. And thereafter, a very few reaction where very special role of this H2O2 is, as in the morning time also I told you, special reaction. Really special. This CrO5 is a blue color compound, is soluble in organic solvent like ether. Ether means ROR. You might be knowing that. ROR. That's how we used to know ether, where R groups are alkyl groups. And the color of this CrO5 is blue that I have highlighted here. Colorless layer of water and ether is there. So be careful that if K2Cr2O7 is given to you in the presence of H2O2, it is going into, my dear, it is going from +6 to +6 state. You can see there is no oxygen evolved, right? So very special reaction. This one I have already given you +3 to +6. You can see that. So the first reaction is a redox reaction, whereas the second one is not. The first reaction is a redox reaction. But not very stable, right? CrO5 is not very stable. Blue colored. Structure I have shown you over here. Butterfly-like structure. You can see that it is not a redox reaction, right? This one is green. I will make it green for you. This is green. I have already described it. This is green going into yellow. And this one is basically orange. Let me see. Yes, I have that color. So this is orange. Dichromate ion is orange. Chromate is green, whereas dichromate is orange. That goes into CrO5, which is blue. So many colors you will get. Interestingly, these things are related with the practicals, but unfortunately, we are supposed to read them as if a theoretical thing is there. Right? So from +1 to 0 state, we are getting, right? So reduction from -1 to, sorry, from 0 state to -1, we are going. And H2O2, as usual, you will get O2, right? From +1 to again -1. From here, CaOCl2, this is having one of the chlorine. This is having one of the chlorine as in +1 state. So that is also going into. You can see that every time we are getting oxygen. So these are special reactions. Whenever H2O2 acts as reducing agent, it evolves O2. Right, so this is the observation, most important observation. Some special. Some special reactions in the sense. You can see there is no redox change happening over here. Okay, so that is one of its unique thing. And H2O2 concentration, all of these I have already told you. Fine, guys. Any other doubt you have here? See, when I was solving this, I was looking at from the redox perspective, right? So I very rarely, there are very few reactions which you need to mug it up. Rest of you can have a nice analysis and you can go to the conclusion. Guys, am I audible?
Yes, sir. Yes, sir.
Okay. So please tell me any other doubt is there. I can go for it. Any other doubt till 10, 15? So do one thing. This one I'm going to share you right now. Just before writing the exam, you just go through it one by one and try to analyze. Don't go straight away and try to mug it up. Try to analyze that what could be the possibility. Are we getting any pattern? If the possibility you are able to guess very easily, then no need to memorize. Only those things you need to memorize which you can't guess nicely. Right? Like if someone is asking what is pentons, that you can't guess now. Pentons is FeSO4 plus. So in that way, if you'll approach, then all of these 50-60 reaction will cut down into hardly 5-10 important reactions. Rest you can guess even if you're not uh, studied it, you can simply have a good guess there in the exam. Guess means it's not a guess, it is basically your analytical ability. But if you'll think that all the 30-40 reaction, unless you remember, you should not solve, then I don't think that's a very right approach, right? So go ahead and try to solve it. Here, as I told you about X volume H2O2 means, as I told you, point number 1, I will write here, molarity X upon 11.2, normality X upon 5.6, third, uh, percentage strength, as I told you, molarity into molar weight of H2O2 whole divided by, tell me, Huh? 10. Or it was basically mass of H2O2 in gram divided by mass of solution. Sorry, क्या कर रहा हूँ मैं? Not mass. Volume of solution in ml multiply by 100 because they're talking about percentage. Or, so this is for H2O2 I'm telling you. So it up to you how you are going to perceive it, how you are going to. I just personally go for this formula and rest I used to derive. Because these small thing I can't do in the exam. How will I expect big things in the exam? Right. So X volume H2O2. For now, you take it like this. Tomorrow, while discussion, please come to the class, everyone. Please attend the paper discussion also if it will happen. I will tell you the derivation of H2O2 from where this X upon 11.2 came actually. Now, if you are interested now, even now also I can tell you. Basically, it is defined like this, that if H2O2, right, 1 liter solution of H2O2 is heated strongly. So obviously after heating, decomposition will be complete. So after completion, if you are going to get V volume of O2 at NTP, V liter of O2 at NTP, in such case, we say this as a V volume H2O2. So instead of writing VV, I should write at X liter. This is X volume. So what is the meaning of X volume H2O2? Means X volume H2O2 means when 1 liter of H2O2 is completely decomposed, we will get X liter of O2 at NTP. That's what the literal meaning of this is. From here, you can derive, isn't it? X liter of O2 means number of mole of O2 will be, sir, we know that X upon 22.4. Now from here, number of mole of H2O2, as we know that O2 is 1 mole, then it is double mole. So double of the number of mole of O2. From here, you can derive it. X upon 22.4, which will be nothing upon X upon 11.2. Got it. You got the mole. From here, molarity is equal to mole upon volume of H2O2. Mole of H2O2. Mole is nothing but 11. X upon 11.2, volume is 1 liter. So this is mole, this is liter. So how much you got? You got X upon 11.2. Got my point? This is how it is derived. So again, I am repeating, X volume H2O2 means when 1 liter aqueous solution of H2O2 is decomposed completely, you will get X liter of O2 at NTP. That's it. So if it is 10 volume means 1 liter of H2O2 on decomposition gives 10 liter of O2 at NTP. If it is 20 volume, which means 1 liter of H2O2, इसको fix करना है, 1 liter ही रहेगा, right? So this will be 1 liter. After decomposition will give, if it is 20 volume, it will give 20 liter. If it is 30 volume, 30 liters. Like that it will be. You got the idea from where this volume leveling is there. Okay. So yes, that's it. I think I don't need to explain much about it. Tell me any other doubt if you have. Otherwise, you just practice it. I think it would be more better, right? So I'm going to forward the notes. That's it for the class, guys. Yeah.
Sir, some in volume strength In some questions, they're using N factor, sir, in redox.
Yeah, they are using. So redox is not covered yet for you guys.
No, sir.
No, sir.
Okay, yeah. And then in that case, it will be a trouble, right? Because if I'll start explaining, I can explain it very quickly. Uh, do you, Acha, how many of you guys know little bit about these n factor and all in the lower classes? How many of you know? See, the complete redox will be explained by anyone who will be teaching you the physical, right? For now, what I can give you, I can just guide you so that you will not face the trouble. So I will guide you. Just please listen very carefully. See, H2O2, whenever it was acting as an oxidizing agent, you remember it was going from -1 to -2. Yes or no? Tell me. If you will respond properly, I will tell you. Yes or no? So that means there is a change of oxidation number 1 per molecule, per atom. But how many H2O2, how many oxygen is there in H2O2? Answer is 2. So how many electron is actually gained or lost by H2O2 per molecule? Answer is 2. So N factor of H2O2 is 2 as an oxidizing agent. Let's look at the reducing agent. When it is going as a reducing agent, it will form O2 from -1 to 0. Again, change is 1. Per molecule, 2 oxygen is there. So again, 2 loss or gain will be there. So again, N factor. So for now, what you have to take, N factor of H2O2, you have to take as how much? 2. As OA and RA. And if you are smart enough, you might be knowing that N factor of H2O2 is 1 in case of auto oxidation reduction, disproportionation. Right? So only in case of disproportionation, only when H2O2 is undergoing decomposition like H2O plus O2, then only you are supposed to take this. Otherwise, in most of the cases, it will be 2 only. So if you are worried about how much N factor will be there in a chemical reaction, so take it 2. Okay. There is one more case where it could be 1 when NaOH is replacing one of the H plus ion. It is non-redox reaction. So here also it could be 1. Here also N factor could be 1. But again, only one H plus. If both is removed, then again 2. So listen, because I am not teaching you the physical, right? So these things are expected in the redox chemistry. Unfortunately, H2O2 is a part of inorganic chemistry, so I am explaining this, right? But please understand, more depth and more question practice you will be doing there. Here I can just assist you. Okay. Here I can just assist you. I can
39th
just
question, can you give that value?
Oh my God, I think my whole thing is discharged, I guess. Is it? Just a minute, please. Sorry. Pencil is discharged. Huh? Which one? Which one you're talking about?
13.
40?
39.
39. The volume strength of per hydrol is. Again, this is a really informative thing. Anyone having any idea about what is per hydrol? I think a very special concentration of H2O2 is taken as per hydrol. Anyone have any idea? Anyone having any idea about per hydrol? What is per hydrol?
Sir,
How much?
I think medicinal H2O.
Yeah, that is okay. But how much concentration? That I know that medicinal one is known as per hydrol. But how much is the concentration?
Sir, is it 30?
I am not very much aware. You can search it.
Sir, 100.
Per hydrol. Let me just check it out. Per hydrol. 30% of weight by volume. 30% of weight by volume is said to be what I found on at one place, that it is 30%. It becomes 30%. So 30% weight by volume.
The volume
So
strength will be 100.
yeah, volume strength will be 100. So volume strength 100, then it is per hydrol. So percentage wise, if you want to calculate, it will be 100. Volume strength, do you remember the molarity expression? 11.2 into molecular weight 34 divided by 10. So basically it will be 10 into 34. So 340 divided by 11.2. It will be approximately
30.
Yeah, it will be approximately 30. So either you say 30% strength or you say 100% volume strength. So then good thing is I should make a note over here. Very, very important. Again, I don't think that these things are required, but because it is there, per hydrol is a solution of H2O2 having volume strength 100. Molarity 100 by 11.2. Percentage strength, you can calculate, right? It will be 100 upon 11.2 into 34 divided by 10, approximately 30%. So that's it. Which solution of H2O2? Aqueous solution. Okay, understood. Yeah, any other doubt?
Sir, day 5, 49th question.
Which one?
Day 5, sir, 49th question.
49th. Which of the following statement are correct, right? That one only. Huh?
Yes, sir.
Okay. So again, you have to look at the reaction. There is no other alternate. But H2O2 oxidizes iron plus 2 both in acidic and basic media. I'm not convinced with it. H2O2 oxidizes Mn plus 2 ion in basic media. Yes, it forms MnO2 in that circumstance. Liberates iodine from Ki solution and reduces I2 to I minus in basic medium. Acidified Ki, that's true. You remember I2 and I2 to I minus in basic medium. That's wrong. It does not reduce I2 to I minus. Means this reaction I haven't seen actually. I2 to I minus, because even I minus is converted into IO3 minus. So I don't think that it should be true. What's the key given for it? 49th?
BCD, sir.
Sorry?
B, B, C, and D.
D is quite doubtful. Just check it out once again. 49. Let me check. 49th. Is it the key? 49th. BCD. Oh my god. So BCD. So B is okay. I don't have any problem. Oh, H2O2 oxidizes iron plus 2 in acidic medium into iron plus 3. Whereas in basic medium, H2O2 actually reduces from plus 3 to plus 2. Right, this is, and so again, I am not agreeing with B. H2O2 oxidizes Mn plus 2 ion in basic media. That's true. H2O2 liberates I2 in Ki. That is also true. H2O2 and reduces I2 to I minus. This is also quite doubtful to me. So for now,
Sir.
I will reserve this. I will just recheck the
Sir.
thing related to that. Yes.
Then what about option
Sir,
A?
55 also same question, but ABC given, sir.
55 also same question. In that case, ABC is given, na? Both in basic medium, both in acidic medium. Okay. And H2O2 ABC given. So
Yes, sir.
so this I'm agreeing. Again, I'm having doubt over this. Again, I'm having trouble over this. So I will figure it out. Okay. I'll let you know. But for now, I think you should just consider this one and this one to the higher extent, right? Still I will reserve this point and I will see. Unless I will verify, I can't say, right? Because the values of this E naught are little different, right? So I have to check. Fine, everyone. So that's it. I guess we did fair amount of job, and we'll see these remaining things tomorrow. If you have any doubt, we can meet once again. Okay. So for now, you can revise the notes and just go through